Assalamu alaikum. I am Abid Hussain. Welcome to the online classes. Today we are going to study about the semiconductors. So first of all, we will discuss about the semiconductors. That what are the semiconductors? So according to the definition, as we have in front of us, that what are the semiconductors? Semiconductors are the materials whose ability to exhibit the electrical conductivity lies between the conductors and the insulators. As we know that conductors are those materials which can conduct the electricity and due to the free electrons present in that material, and the insulator are those materials which are opposite to the conductors. They do not conduct the electricity. So here we can say that the semiconductors are the mediator between the conductors and the insulators here. Because semiconductors have some of the properties of the conductors and some of the properties of the insulators. So semiconductors are furthermore divided into the extrinsic semiconductors and the intrinsic semiconductors. Intrinsic semiconductors we will define, and the extrinsic semiconductors are furthermore divided into the n-type and p-type materials. So now we have the intrinsic semiconductors. These are the chemically pure form of the semiconductor materials, so formed by the tetravalent atoms like the silicon and the germanium. So here we are going to take the example of the silicon here. Silicon, as we know that silicon is bounded by the 4 electrons, and silicon has the 4 electrons in their valence shell. So all the 4 electrons are bounded by the 4 other electrons of the silicon atoms here. As you can see there that there is a covalent bonding between the silicon atoms. It means there is a perfect sharing of the electrons here, and covalent bond mostly depend upon the sharing of the electrons here. So there was an electron. You can see that there was an electron when it will be given the energy. So when this electron, which is pointed out here by the arrow, this will be removed here, and electron, after removing, there will be a hole at the place of that electron, and it will be formed, and this electron will be free here. When this electron will be free, then it will be responsible for the conduction of the electric current here. So where is the energy level diagram in front of you? There is a valence band and there is a conduction band, and there is a big gap between these two, and it is called the band gap here. So whenever we want to give some amount of energy toward the atom which is present in the valence band, it will move towards the conduction band. It means that whenever any electron is given any kind of material such as some amount of the energy, then it will remove from its place, and it will move further towards any kind of the shell or anything else. But here we have the band, so from the valence band it will move towards the conduction band, and it is due to the given amount of the energy. The energy is responsible for the movement of the valence band towards the conduction band here. Now here we will discuss about the extrinsic semiconductors. These are the impure form of the semiconductor materials formed by adding either pentavalent or trivalent impurities into a pure semiconductor atom. Now we will discuss it in detail, that how we can make these kind of the extrinsic semiconductors. So extrinsic semiconductors, as we have already discussed, that these are formed by the 2 types. One of them is the n-type, formed when pentavalent impurities are doped, and the p-type material is formed when trivalent impurities are doped. So these are the 2 types of the extrinsic semiconductor materials, and as we know that some of the so now the n-type material, pentavalent impurity atom phosphorus is doped. It is also known as the donor impurity due to the presence of the extra free electron. As we can see here that phosphorus is the atom whose outermost shell contains the 5 electrons, and from them one electron is free here, and the 4 other electrons are bounded with the silicon atom here. So by the force of the silicon covalent bonding, 4 electrons are bounded, but the one of the electron is free here, and it will be responsible for the flow of the current here. So means if the current will be conducted here, it will be the responsibility of that free electron. If there is any external heat is provided here and the energy, then there will be electron which will leave its place from the bond, and there will be a hole there. So as this hole will be created here, so electron is already a free, then another electron is free here. So these are called the donor impurities here. So the n-type extrinsic materials mostly are known as the donor impurities also, because these mostly give the electrons. So energy level diagram is in front of us here. So the donor energy level do not require more energy to donate its electron, because these can easily donate their electron, and at room temperature it can also give their electron. So the free electron here was responsible for the conductivity, as I have already told you that mostly the conduction band here will be convenient as we have defined in the intrinsic materials. So here we will now define the p-type materials, and trivalent impurity atoms boron is dropped here. It is also known as the acceptor impurity, because this will accept the electron, as we have defined in the n-type material. This is opposite to the n-type material. There was already a hole present in this crystal, so it means there was a requirement of the electron to fill this hole, and it can accept the electron here to fill up the hole. But as we have the other electron free here from the silicon, from the atom of the silicon which is bounded by the boron atom here, so as you can see that there will be an electron which will move toward the hole, and it will fill up the hole here. So again the silicon will have a free electron here. So in this same type there will be a free electron. It will be the responsible for the conduction of the electricity, conduction of the material. So here was the conduction band, and there was a band, and there was a large band gap between the valence and conduction band. So for the electron which is present in the valence band, acceptor energy level, so it will require more energy as for the n-type material to reach the conduction band here. So it means we can say simply that in valence band we have required energy more than the n-type material to reach the conduction band here. So this was all about the semiconductors, and then intrinsic semiconductors, then extrinsic semiconductors, and there are two types. Inshallah we will meet again in the next video. Khuda Hafiz.